The broadcast is now starting. All attendees are in listen-only mode.
Hi, good morning. Can everybody hear me and see the screen okay? Emily, Dave, can you guys hear me?
Yes.
Okay, just wanted to check. And thanks, Brad. Good morning welcome to the Southwest El Nino and Drought Status webinar. My name is Elizabeth Waite. I am a Regional Drought Information Coordinator for NOAA's National Integrated Drought Information System. In today's webinar, I'll provide a brief overview of NIDIS and the Intermountain West Drought Early Warning System, and then Gerry Bell will present. Gerry is a research meteorologist with NOAA's Climate Prediction Center. In his presentation, he'll discuss what El Nino is, how El Nino affects the weather patterns, and the latest El Nino analysis and predictions. And following Gerry's presentation, we'll have Dave Simeral. Dave is an associate research scientist at the Desert Research Institute, the Western Regional Climate Center. He'll share with us information on the status of the drought that has affected the Southwest region for many months, together with a water year wrap-up and impacts of the drought and what El Nino means for the region. After Gerry and Dave's presentation, we'll open the webinar for your questions. Emily Elias, the director of the USDA Southwest Climate Hub, will facilitate the question and answer session. During the webinar, all participants are muted. So if you have a question, please type it into the chat box or the question box that's on the right-hand side of your screen in the GoToWebinar control panel. The webinar will finish in exactly 1 hour, so if you have any remaining questions, you're welcome to email me. And finally, today's webinar is being recorded. The webinar recording and a written briefing report of the webinar will be available on drought.gov. Very briefly, if you're not familiar with the National Integrated Drought Information System, or NIDIS, it was established under NOAA to support research on how and why droughts affect society, the economy, and the environment, and to improve accessibility, dissemination, and use of drought information, and to build a network of regional drought early warning systems across the nation. You can see in the picture there, the diagram, the different regional drought early warning systems. A key aspect of regional drought early warning systems is collaborating and coordinating among agencies that are key players in drought monitoring, forecasting, planning, and communication. Those agencies have been really involved in organizing this webinar to bring you this up-to-date information. This webinar series could not happen without the input and support of many partners, including the USDA Southwest Climate Hub, the Western Regional Climate Center, state climatologists, NOAA's Climate Prediction Center and National Weather Service and Regional Climate Service Directors, Western Water Assessment, National Drought Mitigation Center, and many others. So I send a huge thanks to everyone involved in this effort. And for today's webinar, I'm very pleased to introduce Gerry Bell and Dave Simeral and then Emily. I'm going to turn over the presentation mode now to Gerry.
Okay, do you see my presentation?
Yes.
Yeah.
Yeah, great, okay. Good morning, everyone. It's really a pleasure to be here. My role in this talk today is to discuss El Nino, what it is, how it works, and also the latest predictions for this coming winter. As mentioned, I work with the Climate Prediction Center in College Park, Maryland. If you're interested in updated El Nino discussions and predictions, the link is down at the bottom. The El Nino discussion is updated every month. There's also a weekly update, if it's more technical analysis. And also there's an ENSO blog that I've indicated the link for. So what to expect of El Nino this winter? Right now, we're in an El Nino watch. That means conditions are favorable for the development of El Nino. And I'll talk about what El Nino is in just a minute. I'm just hitting the forecast. There's a 70 to 75% chance of El Nino this winter. In fact, conditions are moving progressively more toward El Nino week by week. Now, for the arid Southwest, El Nino is often crucial for bringing beneficial winter rains snow, building up the snow and ice pack. And this increased precipitation often plays a critical role in helping to relieve or even eliminate drought in the Southwest. So El Nino is a major player in the moisture sources, wintertime moisture for the southwestern U.S. That's why it's so important in this forum. So what is El Nino? El Nino and its counterpart La Nina are opposite phases of a very prominent climate pattern, and that climate pattern is called the El Nino Southern Oscillation, or ENSO for short. These are naturally occurring climate patterns, and they're related to variations in Pacific Ocean temperatures in a particular area. This area is along the equator between the international dateline and the west coast of South America. So it's a tropical climate phenomenon that is large enough to affect our weather patterns. Its impacts, in fact, affects the global weather patterns. By that, winds, storms, storm location, hurricanes, jet streams, temperature, precipitation, not only rain, but also snow. But a key thing to keep in mind is that all El Ninos are not equal. Some are stronger, some are not as strong. So the impacts vary from one El Nino to the next. They vary in scope and intensity based on the strength and spatial extent of the event. And that's important to keep in mind for the winter forecast. If there's uncertainty in predicting the strength of El Nino, there's going to be some uncertainty in the winter predictions. So this is a map showing El Nino ocean temperature departures from normal, and this is for a strong El Nino back in December of 1997. So El Nino refers to when the eastern half of the tropical or equatorial Pacific Ocean is warmer than average. Temperatures can get 3, 4, 5, 6 degrees even more above average. That's a significant warming of the eastern half of the Pacific Ocean. Its counterpart is La Nina. La Nina refers to when there's colder than average temperatures in the ocean across the eastern half of the equatorial Pacific. Now look at the scale of these. You don't normally think of it this way, but these temperature departures extend about a quarter of the way around the globe. So again, very large changes in ocean temperatures over a very large scale. There's a typical life cycle for El Nino and La Nina. They typically last about 9 to 12 months, and they occur on average, say, every 3 to 5 years or so. They typically develop in mid to late summer or fall, as the current trending toward El Nino is consistent with. And in summer and fall, the main impacts are more in the tropics and on hurricane activity. There's not a lot of impacts in the United States other than with hurricanes during the summer and fall. They're typically strongest in winter, and then they dissipate in the spring. The winter is when we in the U.S. have, winter into the spring is when we have our most significant impacts. Impacts on the jet streams, the storm tracks and storm locations. As I mentioned, temperature, precipitation, rain, snowfall, snowpack, and also drought formation, intensification, and relief. And that last one is particularly crucial for the southwestern U.S. We have a very specific way of classifying El Nino and La Nina. It turns out there's many complementary and interrelated measures of these phenomenon. Air pressure patterns, ocean temperatures, tropical rainfall patterns, tropical wind patterns. There's one specific measure that we use for identifying the strength of El Nino and La Nina and also classifying them historically. And so the Climate Prediction Center classifies these events based on what's called the Nino 3.4 index. And what that index measures is area average sea surface temperature departures in that core region I just showed you, the East Central Equatorial Pacific Ocean. And for scientists, that's called the Nino 3.4 region. This is a map, recent map of the Pacific sea surface temperature departures from normal, and these are in degrees Fahrenheit. So this is averaged over the last 30 days. And the purple box here is centered along the equator, just east of the date line. This is the Nino 3.4 region. So it's the area average sea surface temperatures and departures in this area that we use to classify El Nino and La Nina, whether they're there, their intensity, and how they rank historically. Right now, the ocean temperatures are above average. The oranges and yellows indicate above average temperatures. Over most of the eastern half of the equatorial Pacific, they're generally about 1 to 2 degrees Fahrenheit right now. So they're on the border threshold for a minimum El Nino. But right now we're not seeing any impacts in the winds and the rainfall yet. So we're still heading toward El Nino. And as I just mentioned, ocean temperatures are currently warmer than average as we trend toward El Nino. So there's the operational definitions for El Nino are based, again, on this Nino 3.4 index. And when that measure exceeds plus or minus ½ degree Celsius or 1 degree Fahrenheit, along with consistent wind and rainfall patterns, that's when we have an El Nino or La Nina. And those conditions also need to be predicted to persist for 3 consecutive months. So this is the weekly Nino 3.4 index dating from last November 2017 through last week. The Nino index is the blue and going into the red. So the blue indicates when ocean temperatures were colder than average last winter, and then they became near average, and then after June, the ocean temperatures started warming up and have become progressively warmer in recent weeks. We classify El Nino as the red shading when the area Nino 3.4 index is at least plus ½ degree C, 1 degree Fahrenheit. And we classify La Nina when the ocean temperatures are at least cooler than ½ degree C or cooler than 1 degree Fahrenheit. Last winter, we had a La Nina episode. Now we're quickly trending toward an El Nino. So the question is then, that's nice, but why does El Nino and its counterpart, La Nina, affect our winter weather? Well, it has to do directly with how they affect the tropical rainfall patterns. El Nino and La Nina alter the normal patterns of tropical rainfall and convection. That's deep, heavy tropical rainfall and thunderstorms, basically. From Indonesia all the way to the west coast of South America. That's a distance of more than halfway around the globe. And this is specifically why they have such strong and extensive impacts on our weather patterns. So to see this visually, this is a pattern of rainfall departures from normal during a strong El Nino. So what you see is a pattern of the browns, drier than average across the western Pacific, western tropical Pacific and Indonesia. And then the greens indicating wetter than average conditions from the dateline all the way to the west coast of South America. This distance here is more than halfway around the globe. Its counterpart, La Nina, has an opposite pattern, where it's wetter than average in Indonesia and the western Pacific, and drier than average, more centered near the dateline, but certainly extending eastward. These rainfall patterns are important because they directly affect the jet streams. These are such prominent rainfall patterns that they help to affect the intensity and extent and strength of the jet streams. So that's the second part of how and why they affect our weather. The winter weather is controlled by jet streams. El Nino and La Nina affect the jet streams, therefore they affect our weather. This is a pattern, a schematic showing typical El Nino winters impacts over the United States. So what's showing here is the Pacific jet stream, and the Pacific jet stream is the main driver for storms coming into the United States, from Pacific storms coming into the United States. With El Nino, the Pacific jet stream has shifted south of normal, and it's extended more eastward toward the southwestern United States. Normally, the jet stream comes into the U.S. up near Oregon and Washington up here. So this is a significant southward shift of the jet. Where the jet stream goes, so goes the storms. With the jet shifted south, so is the storm track. And as a result, we have stormier, wetter, and cooler than average conditions across the southern part of the U.S., drier than average conditions in the kind of the central U.S., and warmer than average conditions across the northern U.S. and Canada. And with the same jet stream pattern, the polar jet, now that would be the feature that really brings some cold air into the country, that shifted much more into Canada, so we have fewer Arctic outbreaks. So it's these combinations of these jet streams that give the warmer than average conditions across the north, but it's this Pacific jet stream that is the main factor controlling the weather and storminess in the southwest. So El Nino, we look forward to that because wetter, stormier, more snowpack across the south and southwest. So with that, the winter outlooks for this year, we are in an El Nino watch. Conditions are favorable for the development of El Nino. Right now, there's about a 70 to 75% chance of El Nino this winter. And the outlooks reflect that likely El Nino. But keep in mind, again, El Nino impacts vary in scope and intensity based on the strength and spatial extent of the event. And right now, El Nino hasn't formed yet, and meaning it's just too early to confidently predict how strong it will become if, in fact, it develops. So the temperature and rainfall predictions for this winter are reflecting more of a typical El Nino at this time. We indicate our winter outlooks based on probabilities. What are the chances that it'll be warmer than normal or colder than normal? And that's what I'm showing here. So the shading is indicating that warmer than normal conditions are most likely, and then the probability of that, or the chance of being warmer than normal, are indicated by the numbers at the bottom. So right now, we're expecting likely warmer than normal conditions across the western half of the U.S. and extending across the north central and northeastern U.S. So overall milder than average winter temperature-wise. Now here's the same idea for precipitation, and this includes both rain and snow. Because the storm track is expected to be south of normal, it's expected to be likely wetter than normal from basically southeastern California all the way across to the Carolinas and then up the mid-Atlantic. Fortunately, this is likely wetter than normal conditions for severely drought-stricken areas, especially in the Four Corners region. Now, conversely, because that jet is shifted south, we're expecting drier than average conditions up into the northern plains and also portions of the north central Midwest. So to take a look at that, what it means in terms of drought, this is current drought conditions as of October 16th. And this is from the U.S. Drought Monitor. So the shadings here indicate intensity of drought. Where it's white, there's no drought. Light yellows, abnormally dry, progressively to reds indicate extreme drought, and then the brownish indicates exceptional drought. So this is that Four Corners area of severe drought that I was talking about, extending way down into Arizona, New Mexico. There's also extreme drought up in Oregon and severe drought extending up into Washington state. But a lot of the western U.S., basically, you can see, is in some sort of moderate to severe or extreme drought, and only very limited regions of the West are not in a drought at this time. Now, based on forecasts, and I'll show more detail on this in just a minute, the green circles here indicate predicted areas of drought relief and or drought removal. So El Nino, if it develops, is expected to significantly improve drought in the southwestern U.S., but not all of this really bad drought area. It's also expected to relieve drought from northern California up through western Oregon and into western Washington state. So here's a more detailed picture of the drought outlook, and this is through January 2019. The brown shadings here indicate that drought's likely to persist at its current intensity. The light browns here, these grays indicate drought is going to remain but improve. Greens indicate drought removal is likely. And yellows indicate where drought would develop, and there's no yellows at this time, so there's no new areas of drought expected this winter. So you see, again, in California, New Mexico, up into Colorado, Arizona, New Mexico, into southern Utah and southwestern Colorado, large areas where drought is expected to improve or end. Also up in Northern California, Western Oregon, and Western Washington State, drought improvement or drought ending. But unfortunately, if you look at Eastern Oregon, down through Utah, down through Southern California, the current drought conditions are expected to persist. So in summary then, we're in an El Nino watch. Conditions are favorable for the development of El Nino in the next month or two. It's too soon to predict how strong El Nino will become. Stronger it is typically means more rainfall and more storminess across the south. Expect typical El Nino impacts this winter if it does develop, and those would be, as we're predicting, an increased likelihood of above average temperatures across the western half of the country and also across the north central and northeastern U.S. Expect an increased likelihood of above average precipitation, snowfall, increased storminess across the southwestern and southern U.S. And as far as drought goes, expect the most improvement from drought in both the southwestern and the northwestern U.S. But unfortunately, at this time, expect significant drought to persist at roughly its current intensity in large portions of Southern California, eastern Nevada, most of Utah and Colorado, and also the eastern half of Oregon. So that's what I had to present, and I'll turn it back over to the moderators.
Okay.
Well, thank you for that. If anyone has any questions for Dr. Bell, if you could please type them into the question box. And now we're going to move to our next presenter, Dr. Dave Simeral.
Hi, can you hear me?
Yes.
Okay, and can you see my presentation on the screen? And can you see my presentation?
Yes, it's up. It looks good.
All right, thank you. Thanks, Gerry. My name, again, is Dave Simeral from the Western Regional Climate Center. I'm going to get started here because I have quite a bit of material to move through. So my presentation outline, I'm going to be looking at the current drought status in the Southwest. I'm going to be giving a water year 2017 wrap-up of the conditions. I'm going to take a look at the impact of monsoon last summer. I'm going to talk a little bit about the October precipitation events experienced in the Southwest and look at the hydrologic conditions and kind of expand a little bit on what Gerry was talking about in regards to what El Nino means for the southwestern U.S. So Gerry just showed you this map again. This is the western U.S., the current Drought Monitor map. And looking at the Four Corners states, most of the region is still experiencing drought, ranging from moderate to exceptional drought. Large precipitation deficits still exist in the Four Corners, San Juan Mountains, Sangre de Cristo Range areas. Monsoon season rains and this recent precipitation events we've been having in the desert Southwest this month have helped to provide some relief in the region. Low reservoir levels are definitely something that we're keeping an eye on here, and we're experiencing those across parts of the region. And just as of last week, the governor of Utah declared a state of emergency due to drought. This is taking a look at the 1- and 3-month change maps from the U.S. Drought Monitor. So I want to give you an idea of the impact, I think, since the last Intermountain West webinar earlier in the summer. And the one on the left is the 1 month change, and that's looking at some of the impacts from these recent storms. So we've seen quite a bit of improvement across mainly in Arizona, but also portions of central Utah, western Colorado, and some storm activity from Texas that's kind of gone over into the impacted eastern portions of New Mexico. And on the right is looking at the 3 month change, and you can kind of see the difference in the number of, and those are the deeper the color, the more changes in classification. So you can see quite a bit of improvement between monsoon season and now. It's kind of just giving us a picture of where we stand right now in terms of drought. These are some objective blend drought indicators that the CPC puts together, and they blend a variety of different drought metrics, and you can see the configuration down in the bottom left, excuse me, let me get back to these, in the bottom left-hand corner, and you can see it over here for the longer term, the configuration. So the short term, we can see the recent rains that we've received in Arizona have really made an impact. It's been really wet, so we're seeing quite a bit of relief in Arizona, as well as Utah and parts of New Mexico, but not looking quite as good in the longer term, where you've got quite a bit of kind of D2, D3 level drought that's showing up in the indicators across much of the West, but kind of the focal point is in the Four Corners area. Taking a look at the current drought impacts. This is a map on the right. This was taken, I pulled this yesterday. And these are all, each one of those dots is a USGS streamflow gauge. And these are a number of gauges, these gauges that are below normal. And you can see down on the bottom here how low as far as percentile ranking. So any of these three classifications on the left-hand side mean that they're flowing really low at this point. And this is basically the product of really poor runoff in a variety of the mountain ranges and warm temperatures over the summertime. In Arizona, we're still seeing, despite the rains, we're seeing reports of dry ponds and small springs that aren't running in the White Mountains, which are in the central kind of eastern portion of Arizona, as well as the Cheska Mountains, which are up on the Navajo Reservation, skirting the border of Arizona and New Mexico. We've seen some improvement in rangeland conditions in southern and northwestern parts of Arizona. This is probably pretty short-lived because grasses are generally going into dormancy this time of year, but there has been some green up. Looking at Colorado, we're getting reports of wells running dry and water hauling in south central Colorado, as well as wells running dry in Teller County, which is kind of east of Colorado Springs area. In the northwestern part of Colorado in the Yampa, individual junior water rights, people with junior water rights are having to cease diversions until those with senior water rights needs are being satisfied. And looking down by Durango, Colorado on the Animas River, it's recorded its lowest flows in the 107-year record just this month. Moving over to New Mexico, Rio Grande has pretty much dried up as of July, and the natural flows have stopped, although there is some water flowing in relation to water diverted over from the San Juan Chama project. Also, we're seeing some impacts in terms of fish die-offs and decline on the Pecos River in relation to low flows and water temperatures. And as I mentioned, in Utah, they've declared a state of emergency due to drought just last week. And there's ranchers and farmers, primarily in southeastern and central Utah, that are really struggling to keep their farms going. And this is taking a look at the seasonal drought look that Gerry had also shown. And it's supposed to show some improvement in Arizona and New Mexico, as shown here in the green areas. However, I'm a little bit, I would say I'm a little bit hesitant to say that there's going to be drought removal in these areas, because we do have some longer term hydrologic impacts in terms of low reservoirs in Salt River system, in the Verde River, in central Arizona, and as well as we've got some long-term issues in New Mexico as well, with the largest reservoir in the state, Elephant Butte, which is very low at this time. So taking a look at the water year, this is kind of a review of the water year. Again, is October through September, the end of September, so it just ended. And if you take a look on the right, this is water year precipitation percentiles, and you can see the warm color areas. This area in the Four Corners region is kind of like a bullseye, the crosshairs on that area. Those had the record driest precipitation for the water year in those areas that are red. And that's primarily the product. If you look over to the map just to the left of that here, these are the snow water equivalent percentiles as of April 1st of 2018. So this is coming out of the winter and into the spring months. And the areas, each one of these dots is a NRCS SNOTEL station, which measures snowpack in the mountains. These are high elevation weather stations, and they measure snowfall as well. And the ones with all the red dots on them, you can see a lot of them, and we have, especially over the San Juan Mountains in southwest Colorado, the Sangre de Cristo Range, which is in north central New Mexico and extends up into south central Colorado, as well as we've got a lot of record low measurements at stations in the ENSOs, as well as in the mountains in the central part of Utah as well. Some good news for eastern parts of the state, both of those eastern Colorado and New Mexico. Much of those areas were near normal, and some areas were slightly above normal. Here's another way of kind of looking at the water year, and this is actually an image and some work that's done by some colleagues at Scripps, Mike Dettinger and others, Marty Ralph. And what this is, basically, they're looking at precipitation, the odds of the water year precipitation, 2018-19 reaching 100% of normal precipitation. So this is looking at the precipitation that's fallen up until this time at the end of this September, and looking ahead into the water year. And basically, this is showing that the odds of reaching, so for this 2-year period, the odds of catching up essentially to 100% of normal precipitation for the 2-year period are pretty low, because those deficits just don't disappear. So you can see in these areas where it's white, the odds are very low for the precipitation that would fall this winter, that it would make up for the deficits that occurred over the past year. There is some change in this because this map was made at the end of September. I would imagine that some of these areas in kind of southern and central Arizona that had some big rains this part of the month will have increased odds of reaching 100% of normal for the 2-year period. Looking at the water year temperature for this past year, the percentile map here again is on the left. These areas with the dark red are all areas that experience record hot temperatures. You can see mainly, you see those in Arizona, New Mexico, and Colorado. So it was the warmest 12-month period, the October through September on record for the 123-year record for the Southwest region, and the hottest statewide for Arizona, Colorado, and New Mexico. On the right, these are the actual temperature departures from mean, and you can see they were quite a bit above normal, 2 to kind of 5 degree range. Moving on to the monsoon season, map on the right, I wanted to give you an idea of just the impact of what monsoon season means to parts of the Southwest. So these are 2 different maps. They're the same maps, but they represent just different time periods. The top one is the complete 123-year record. The bottom is kind of a more recent trend in the last 15 years. But what this tells us is the amount of annual precipitation, the percentage of it for June or July, August, and September, what median percent of the annual precipitation falls in those months. So you can see in the areas where it's blue and the darker, deeper green colors. So you can see in like southern Arizona and southern portions of New Mexico, monsoon season, those 3 months represent about 50 to 65% of the annual precipitation. So it's really important for them to get precipitation during that time period, or else during the cool season, they have less of a likelihood of getting that precipitation and making it up. So looking at the left-hand side, this is the map percentage of normal, July through September. You can see as monsoon is characteristically pretty spotty, the areas that are white are kind of normal amounts for compared to the average. The areas further north, you can see it was really dry in the western half of, in the mountains of Colorado, northern portions of Utah, as well as in the Four Corners region. And again, you can see how dry it is up in northern Utah, but if you look at these maps again, it only accounts for a smaller percentage of their annual precipitation. This is more of a close-up looking at, just briefly, this is precipitation percentage difference from average, and this is again monsoon season. I just wanted to give you a little close-up of kind of how spotty the monsoon was this summer. The metro areas fared pretty well. You can see Phoenix had above normal precipitation this summer, as well as the Albuquerque area as well. Tucson, well above average in the southwestern part of Arizona as well, is up in the central portions of Arizona, which is, that was a good thing because this area in the Verde Basin has been really dry, and up in the northwestern part of the state. But unfortunately, that Four Corners region has stayed dry, not only through the winter, but in the summer months. Moving over to Colorado and Utah, again, looking at the maps here, we've got some above average precip down in the southwestern part of the state of Utah. Rest of the state below normal. Colorado mountain areas you could see are all below normal. Although the eastern portions of Colorado fared pretty well this summer. Take a look at monsoon season temperatures above normal across the west. And you can see those areas again with the dark, the maroon colors. Those are record temperatures in those areas. And for the Southwest region, which includes the Four Corners states, it was the warmest July through September period on record. And it was also statewide the warmest July through September for Arizona, Colorado, and Utah, and fourth warmest for New Mexico. And these numbers here are the temperature departures for those periods. So it was 3 degrees above normal and about 3 for Colorado and 4.4 for the state of Utah. Looking at the last 30 days, it's been an interesting wet period for much of the Southwest. We've had cooler than normal temperatures. And we've had two major precipitation events in association with the remnants of Hurricane Rosa and Sergio. We've also had several other precipitation events, and they've actually continued over the last several weeks as well. And but pretty impressive rainfall totals this month in Arizona, as you can see in kind of the southwestern and central part of the state. Really good rainfalls there, looking at 5-6 inches of rain, and those are we'll wait till the end of the month to see how they end up in terms of records for the state. But Phoenix has already had the wettest October on record. Moving over to New Mexico, they haven't fared quite as well, but they've had some pretty decent precipitation for the month as well. In the southwestern corner of the state, over the kind of this in the headwaters of the Gila drainage basin area, they've had some pretty decent precipitation there, as well up in the central part of the state. And oh, by the way, this was a photo from this is during Hurricane Rosa, the remnants from that, and this is a picture the National Weather Service took. This is Phoenix Sky Harbor Airport, and this is the Salt River, which generally is dry unless we get some really major precipitation events, and you can see there's water flowing in the salt. Taking a closer look at precipitation in the Phoenix metro area from Rosa and Sergio on the left-hand side, you can see Rosa, we have widespread precipitation of kind of 2 to 3+ inches around the Phoenix metro area. And Sergio, we're looking at about 1 inch to 3 inches. Moving up to Colorado and Utah over the last 30 days, again, they've also received some pretty good precipitation in western and northwestern portions of Colorado. As you can see, these are the actual observed values. Below is the percentage of normal for the last 30 days. You can see well above normal in kind of that northwestern area, as well as in the eastern part of the state. Unfortunately, these areas here in kind of the south central part of the state, these are kind of in the headwater areas of the Rio Grande, were really dry and not get as much precip. And I just grabbed a couple of these are MODIS images, satellite images just from a couple days ago to show you there were a couple early season snowfall events that impacted Colorado, as well as Utah, northern New Mexico, and northern Arizona. And this is just showing some of the spatial extent of the snowfalls. This is, although I looked through the SNOTEL stations, and kind of snowfall amounts ranging from about 1 inch to 12 inches in areas, but this is a positive start for the San Juan Mountains, which were really dry last year, record lows there, as well as the Sangre de Cristo range. This is moving over to Utah, and you can see some early season snows up in the Uintas, which were hard hit last year as well, and some of the central parts of the state. This is a really positive start. Looking at reservoir conditions across the western U.S., you can see there's no data in for Arizona, but I'll elaborate more on that in a minute. Looking at Colorado, this is the average where we normally are this time of year, so you can see we're below normal as far as reservoir storage for the state. Moving over to New Mexico, well below their average. And looking at Utah is sitting pretty good right now. Moving on to some of the hydrologic conditions in the Colorado Basin. Lake Powell is about 45% full. Lake Mead, 38% full. I took a screenshot from the Lake Mead Marina just a couple days ago, and you can see the bathtub ring around Lake Mead. That's definitely not looking that great right at the moment. And these are some teacup diagrams, and what these show you, this is the total capacity of the reservoir, and you can see here Lake Powell is about 45% full. Some of the areas in the headwater region up in the upper green did pretty well up in this area of the mountains in Wyoming, as opposed to down lower in the basin here in the upper Colorado River Basin. The upper reaches had some well above average snowfall, and that's why you see Flaming Gorge Reservoir is right in this area here, and that's about 90% full right now. Moving over to Arizona, and some of these teacup diagrams I have are different depending on who made them. I think these ones are really nice. What this shows us is the reservoir average for this time of year in red, and the black dotted line is last year where it was, and then the current volume is in the blue. So you can see Lake Powell below normal from last year, as well as from their long-term average, as well as in the Salt and the Verde River system. They're about down 16% from a year ago, and this is because of White Mountains, which are right in this area in kind of the central eastern part of the state, as well as the Verde River Basin were well below normal with precipitation last winter. This graph I put together here, this is precipitation in the Salt River Basin, which is right here. And basically what this is, starting in about 1980 to present, this is the average precipitation for the basin. And the blue is times when it's above average, and red is below average. And you can see just how far below average. It was about half the normal precipitation in that basin last year. Moving over to New Mexico, again, largest, as I mentioned earlier, the largest reservoir in the state is Elephant Butte, really bad shape. That's about 3% of its capacity right now. And you can see further up in the basin, some of the reservoirs up there are also all below normal in those areas. Again, looking at some of the headwater precipitation that feeds the Rio Grande. These are the headwaters up into south central Colorado. And again, you can see well below normal, as well as the Upper Grand, and this is Rio Grande, which is in northern New Mexico, north central, well below normal. Colorado is doing a little bit better than some of the other areas, although the southwestern part of the state, those drainages in San Juan, Dolores, Animas, and San Miguel are all well below normal, as well as the upper Rio Grande Basin. Some of the other basins, the Yampa and the White, Colorado, South Platte, Arkansas, are all looking a little bit better. This is a photo a colleague took just a couple weeks ago up at Blue Mesa Reservoir, and this is kind of in this area over here. And basically this is on the Gunnison Basin, and that reservoir is well below normal. You can see that's about 31% full at the moment here, as you can see in the teacup. Again, precipitation in that basin, you can see that's about little over half of normal. And then in the upper San Juan Basin, same thing, really poor as far as precipitation last year for the water here. Go to Utah, looking pretty good in the northern basins. Reservoir conditions are looking closer to normal up there, but where we're seeing some really low ones, some of these smaller basins in the central part of the state, this is like Gunnison Basin, or the Gunnison Reservoir, where it's at 0%. It's in really bad shape, lowest on record. And this kind of area right around here, the Escalante Desert Basin, is pretty poor shape at 18% of normal. So talk a little bit here about the El Nino, and these are a different forecast model. Gerry showed us the CPC outlooks, which I have here inlaid in both sides. These are from the North American Multi-Model Ensemble, which is a seasonal forecasting model it takes an average of 8 different models. And these are what they're showing for November, December, and January, as well as December, January, February. And what they're showing is kind of above normal precipitation in southern half of Utah, as well as kind of parts of northern Arizona. Kind of looking the same, moving into that December, January, February. And moving on to what ENSO means as far as climate extremes in the Southwest region, and this is looking at the Four Corners states. And what this is a plot of the 5 wettest years, the 5 driest years. So here are the 5 wettest years, and this is looking from, and these are October, this is for the water year basically. So this area on the x-axis is the entire water year. And this is the cumulative precipitation on the right, and this is average over the whole Southwest. So you can see your 5 wettest years occurred during El Nino events, 3 of them, and 2 of them have been during neutral years, while the 5 driest have occurred during mainly during La Nina years. So pretty kind of clear signal, especially in terms of La Nina events. And this is the blue line is our current water year, so it's not looking good as far as falling into the bottom extremes. Now, Gerry had mentioned not all El Ninos and La Ninas are the same, and I wanted to talk a little bit about precipitation anomalies associated with El Nino. And I'm not going to go over all these maps, but basically these are composite precipitation anomaly maps versus the long-term average. So this is taking an average of precipitation in each one of these climate divisions for the 81 through 2010 period. And then it's taking an average of all the precipitation for all the El Ninos and seeing where it stacks up. So what you're seeing is kind of where there's not a clear signal. It's good. You're seeing some wetter than normal for all El Ninos in central portions of Arizona and along the coast of California. Now and that's all El Ninos. Now it becomes clear with some of the signals with a very strong El Nino. And again, keep in mind that we're looking at a very small number of historical events that we're comparing some of these two. So we don't have a lot of data on this. These are the 3 very strong El Ninos on record. And you can see that 2015-16, as you recall, was supposed to be a really wet year in the Southwest, and it ended up being a real bust. But in general, you're seeing wet conditions on very strong El Ninos across much of the Southwest. This is looking at a strong El Nino, and again, you're seeing above normal precipitation, Arizona, southern Utah, parts of New Mexico, and kind of near normal in other parts of the region. And then looking at moderate El Ninos, the signal becomes a little less clear, a little bit above average in one climate division in Arizona, and to where we are now with a weak El Nino predicted. And these are the number of events that it's comparing it to where there were other weak El Ninos. And you really, I kind of would say flip a coin. You're not getting a clear signal as far as whether it's going to be wet or dry. So you're more in that kind of average area. This is taking another look at it. These are some products that we developed here at the Western Regional Climate Center. And these plots look at the Southern Oscillation Index. And this is one of the indexes and other ways to take a look at ENSO, El Nino and La Nina events. And this is looking at the Southern Oscillation Index and precipitation relationships. This is Arizona and New Mexico. And these look a little complicated, but I'll try and explain this here quickly. This is the statewide precipitation on the y-axis These are the La Nina, El Nino, and neutral conditions. So these areas here in the middle, these dots represent a year's worth of precipitation. And these are all the neutral conditions. These are all the La Nina in the blue. And these in the red are the El Nino events. And this is going back to 1933 through just this last year. These lines across, this is the mean precipitation in red here for El Nino events in Arizona. And this is the mean for neutral in Arizona. And the black is for all. And the blue is La Nina. So in Arizona, you can see we've got a pretty clear signal during La Nina events for below normal precipitation. With neutral events, we've got a big, falling around average to below average, but we also have some of the record highest during those. Now I've drawn a box around on each one of these plots of the weak El Nino. Here's the 0.5 through 1. And basically what you see in Arizona is you've got a lot of variation in precipitation during weak El Nino years. So you can see we've got a number of them that are below the average for El Nino years and just the overall average precipitation. So there's no guarantee here that there's a wide variety of outcomes that can occur. Moving over to New Mexico, kind of the same story. You've got some really wet years during weak El Ninos. You've got some clustered around the means, and then you have some well below normal as well. Moving over to Colorado, if you look at all the differences between, here's the mean for El Nino, all conditions, and this is the neutral and the La Nina. They're all kind of, there's not a real good relationship here. So what you can see though is we've got with La Nina, clear signal, it's more below normal. But again, looking over at the weak El Nino, we've got a wide variety of outcomes again. There's a lot of variation. And the same thing looking over at Utah as well. Okay, so this is getting close to wrapping up here. So thanks for bearing with me. This is the same model, the NMME seasonal forecast, and these are for temperature for the winter. And you can see this is in agreement with the CPC models for above average temperatures for the winter. And why I brought this up and why this is important, this is from one of our products. It's a freezing level tracker. And essentially what this freezing level tracker does is basically we can take a look at a specific geographic area. And this is based on reanalysis data of upper air temperatures. And what we can do is figure out the average freezing level elevation for different areas. So I picked out 4 areas at differing latitudes and longitudes within the region. So we've got this is Park City, Utah, Flagstaff, Arizona, Telluride, Colorado, and the San Juans, and Santa Fe, New Mexico. And for the month of January, I chose January. This is the mean freezing level in January, and this is from the late 40s moving into present day. And the mean freezing level for the month of January up in Park City is about 4,600 feet. Looking down at Flagstaff, 7,800 feet, Telluride, 5,900 feet, Santa Fe, 7,300 feet. And what you can see here is since about the year 2000, you can kind of take a look. There's a trend in all these areas with increasing freezing levels in the middle of winter. So you can see in some of these areas, like in Flagstaff, Arizona, the freezing levels in January are getting up as high as over 9,000 feet, up to over 10,000 feet. And why that's important is in the case that we even do have a wet winter in the region, we may have more potential for rain and less potential for snow in the mountains, which has an impact going into the summer and filling those reservoirs. So if we have higher snow levels, snow is in the higher reaches of the mountains, we're going to have a smaller reservoir from from the mountains to supply and replenish those reservoirs moving into the summer months. And this is not saying that there can't be colder snow events and periods within the winter, but I just wanted to show you just kind of the trend in these freezing levels that are going up. So that moves that that dividing line of rain and snow further up. Okay, so closing thoughts. Large areas of extreme and exceptional drought remain across the region, with the Four Corners region as kind of the focal area of drought presently. Despite a promising start to the water year, we'll have some substantial longer-term deficits that remain across the region. And although we, as you can see in the outlooks that were showed earlier with the drought outlooks, there may be some improvement, but I can't see these kind of longer-term hydrologic impacts as far as reservoir conditions going away over the winter because of the large deficits that have been mounting. The anomalously wet October has provided some short-term relief, and this is mainly being shown in improvements to rangeland conditions, as well as stream flows have picked up. Again, hydrologic impacts are a critical issue moving into the new water year. El Nino does not always equate to wet winters in the Southwest. The chances are better than events for above normal precip. And weak to moderate El Nino intensity El Nino events tend to display a wider range of potential precipitation outcomes and strong El Nino events in the region. And that's all I have for you. Thank you.
Thank you very much. This is Emily Elias with the Southwest Climate Hub, and I'm cognizant of our time. We are a few minutes over. Our apologies for that, but there's a lot of information that needed to be presented, so thank you for that. We will try to keep our presenters on the line to get through the 4 main questions, and we will post those on drought.gov with the transcript. So if you're unable to stay on this webinar, you could get the answers there. The first question that I'd like to address could be answered by either of the presenters, but we'll go with Dr. Simeral first, and that is, does the jet stream track change based upon the strength of El Nino? So for instance, does the jet stream sink further to the south when El Nino is strongest? And I'll type your answer.
Yeah, I'll let, I can answer some on that, but I think I'll defer to Gerry to answer that.
Great.
Sure, and the answer is yes. With stronger El Ninos, there's more of an impact on the tropical rainfall patterns, and so as a result, the stronger El Ninos bring that Pacific jet stream even farther to the east and more to the south. With a weaker El Nino, the jet stream is impacted more back near the date line, so there's still a lot of variability downstream as we get to the U.S., which results in more variability, as we were both mentioning, in weather patterns. So strongest El Ninos are when you have the most systematic and intense effects on the jet stream.
Okay, thank you. Thanks for that. The next question is more broad in scope, and I believe that it relates to our changing climate. And the question is, when do we redefine normal precipitation and temperatures? And so I think we could all discuss that for a long time, but if anybody has a quick answer that they'd like me to record here, I'll be glad to do so.
Well, the climate normals that we use are based on the 30 years, so 1981 to 2010. So in 2020, we'll switch the normals to 91 to 2020. And that's based on World Meteorological Organization standards.
Okay, thank you. And the other questions were sent earlier, and they are near the top of the question box. The first one, are analog years incorporated with short and medium term Rossby wave trends to seasonally forecast the winter months during El Ninos? It's at the top, and I can repeat it if I read it too quickly, but it's a question about forecasting winter precipitation during El Nino events.
Yeah, this is Gerry. The main predictor for the winter would be El Nino's presence and its strength for this particular event. In general, fall weather, in the absence of El Nino or La Nina, fall weather patterns really are not a predictor of the upcoming winter patterns. So are they, so the question, are the Rossby waves, no, we don't really look at October itself, October, November, to see what's going to be there this winter. The El Nino signal would dominate that.
Okay. Got it. Thank you for that. And the final question, thanks everyone for sticking with us, is do you look at both the strength and type of El Nino to forecast seasonality? So are you incorporating the strength?
Absolutely. And the type of El Nino, they're referring to a situation where in some El Ninos, the warmer water tends to be more focused near the date line. And in other El Ninos, you tend to be much more extensive with the warmth. So that's what I had mentioned, that aerial extent of the warming as well as its intensity are certainly both factors that we use in trying to predict the upcoming winter. And since there's uncertainty regarding now in exactly how strong El Nino will become, that's why these precipitation and temperature forecasts are indicated in terms of probabilities rather than specifics. For instance, we got about a 50% chance of above average precip across the south. If this were a more significant El Nino already in place, those numbers would go up quite a bit.
Okay, thank you. And two more questions just came in. Will the current negative New Zealand index also contribute to drier than normal outlook for California this winter?
Gerry, again, I'm not sure what that index is. The forecast for this winter, the outlook for this winter is really reflecting the increased likelihood of El Nino. Now, typically with El Nino, again, it's drier than average conditions in the western part of the Pacific, wetter than average conditions in the eastern part. So that rainfall pattern is what the winter forecast is based on.
Okay, thank you. And the final one is a question for Gerry. The drought outlook did not have any areas of likely drought expansion. However, if the strength of the El Nino does increase as it evolves this fall and early winter, are you concerned that the area of drought and related impacts would likely expand northward from the Four Corners region?
Well, the stronger the El Nino, the more precip we would have over a more extensive area would be the most likely scenario. So that would increase the likelihood of reducing drought more toward the north than what the current drought outlook indicates. The current drought outlook is reflecting, again, the wintertime forecast for some El Nino impacts, but really not entirely sure how strong or how extensive. Now, also the more stronger El Nino, if the jet is locked more to the south, that could be a more extensive drought up in the more towards the northwestern U.S., Oregon, Washington, and across the northern part of the country. Maybe see some extension of the drought, but that's not being predicted at this time.
Okay, thank you. And it seemed as though some of the the final slides that Dave Simeral presented also spoke to the variability that may occur.
Absolutely, and both of us really, try to make that point clear. El Nino is not a guarantee, but El Nino certainly increases the likelihood of some significant rainfall in the drought area, the southwestern U.S. drought area, which is why we're talking about it. Rather than with La Nina, if this was La Nina, we'd be saying, oh, wait a minute, this drought could well intensify.
Okay. Well, thank you very much. Thanks, everyone. Our apologies for going a few minutes over. Our organizing team thanks Dr. Gerry Bell of the NOAA Climate Prediction Center and Dr. Dave Simeral with the Western Regional Climate Center. As a reminder, this presentation has been recorded and will be posted on the drought.gov website. Thank you for attending our collaborative webinar on El Nino and drought in the Southwest. When you close this webinar, 2 quick questions will pop up. One on feedback about this webinar, and one requesting your ideas for topics for future webinars. We'd be grateful if you take a minute to respond to those questions. And this concludes the October 2018 Southwest Drought webinar. Thank you.